Hello friends, I'm Jagdish Pug Associate. Today's topic is engineering mechanics. So in engineering mechanics, I will be explaining a numerical problem from the chapter friction. So before going to this video, please press the subscribe button of our channel, the Mechanical Engineers Team, and also click the bell icon so that you will get the notifications for new videos. So let's begin. First I will read the question. An object of weight 120 Newton rests on a rough horizontal surface. Mu is equal to 0.3 and is acted upon by a force applied at an angle of 30 degree to the horizontal. Find the force required to just cause the object to slide over the surface. Now I will analyze the question. Here is the picture of the object. The object is placed on a rough horizontal surface. The weight of the object is 120 Newton. An inclined load P is applied on the object. The inclination of the load P is 30 degree with respect to the horizontal surface. The inclined load P is the pulling force which tends to pull the object towards the right side. The coefficient of friction between the object and horizontal surface is 0.3. In this question, we have to find the magnitude of P which is required to pull the object towards the right side. Next, I will list out the given conditions from the question. First, weight of the object, which is 120 Newton, and it is taken as W. Second, coefficient of friction, which is 0.3, and it is taken as mu. By using these two conditions, we are going to find the magnitude of P, which is required to pull the object towards the right side. Now I will move to the solving technique. First, we will draw the free body diagram of the object. Generally, the free body diagram represents the number of forces acting on an object. So this is the picture of free body diagram of the object, and the number of forces acting on the object is 6. And the 6 forces are, first one is weight of the object, and the direction of weight of the object is downward. Therefore, the sign convention of weight of the object is negative. Second one is the normal force. Normal force is the force applied by the horizontal surface on the object. Okay. When the object is placed on the horizontal surface, the normal force will be automatically developed in the horizontal surface, and this normal force will be applied on the object. Okay. And the direction of the normal force is upward. Therefore, the sign convention of normal force is positive. Third force is the friction force. Friction force is the force which is acting between the horizontal surface and the object. The direction of friction force will always act opposite to the direction of pulling force. So the direction of pulling force P is right, and the direction of friction force will be left. The fourth force is inclined load P. The fifth force is vertical component of inclined load P, which is force PV. The direction of force PV is upward. Therefore, the sign convention of force PV is positive. Sixth force is horizontal component of inclined load P, which is PH. The direction of force PH is right. Therefore, the sign convention for force PH will be positive. Next, we will find the values of horizontal component of inclined load P and vertical component of inclined load P. For that, we will use trigonometric formulas. So first we will find the value of horizontal component of inclined load P, which is PH. For finding the value of PH, we will use the formula of cos theta. And the formula is cos theta is equal to adjacent side by hypotenuse side. So here adjacent side is PH, hypotenuse side is P, and theta is 30 degree. And the next step will be cos 30 degree is equal to PH by P. Now bring this P to the LHS. We get PH is equal to P cos 30 degree. In this RHS, cos 30 degree is 0.86. So the next step will be PH is equal to 0.86 P. And consider this one as equation 1. In equation 1, the horizontal component of inclined load P is 0.86 times of inclined load P. Okay. Now we will find the value of vertical component of inclined load P, which is PV. For finding the value of PV, we will use the formula of sin theta. And the formula is sin theta is equal to opposite side by hypotenuse side. So here opposite side is PV, hypotenuse side is P, and theta is 30 degree. So the next step will be sin 30 degree is equal to PV by P. Now bring this P to the LHS. We get PV is equal to P sin 30 degree. In this RHS, sin 30 degree is 0.5. So the next step will be PV is equal to 0.5 P, and consider this one as equation 2. So in equation 2, the vertical component of inclined load P is 0.5 times of inclined load P. Okay. Next we will find the value of friction force, which is taken as F. For finding the value of F, we will sum up all the horizontal forces acting on the object. So the total number of horizontal forces acting on the object is 2, and the two horizontal forces are the horizontal component of inclined load P, which is force PH, and the friction force, which is F. Now we will sum up these two forces and equate it to 0. We get PH plus of minus F is equal to 0. So here plus of minus is minus. So the next step will be PH minus F is equal to 0. Now bring this F to the RHS. We get PH is equal to F. Consider this one as equation 3. Now substitute equation 1 in equation 3. What is equation 1? Equation 1 is PH is equal to 0.86 P. By substituting equation 1 in equation 3, we get F is equal to 0.86 P. Consider this one as equation 4. Next we will find the value of normal force, which is taken as Fn. For finding the value of Fn, we will sum up all the vertical forces acting on the object. So the total number of vertical forces acting on the object is 3, and the three forces are weight of the object, vertical component of inclined load P, and normal force. Next we will sum up these three forces and equate it to 0. We get Fn plus PV plus of minus W is equal to 0. So here plus of minus is minus. So the next step will be Fn plus PV minus W is equal to 0. Now bring this W to the RHS. We get Fn plus PV is equal to W. And consider this one as equation 5. Now substitute equation 2 in equation 5. We get, what is equation 2? Equation 2 is PV is equal to 0.5 P. So by substituting equation 2 in equation 5, we get Fn plus 0.5 P is equal to 120 Newton. Now bring this 0.5 P to the RHS. We get Fn is equal to 120 Newton minus 0.5 P. Consider this one as equation 6. Now we will find the magnitude of inclined load P. For finding the magnitude of inclined load P, we will use the formula of friction force. And the formula is friction force is equal to coefficient of friction into normal force. That is, F is equal to mu into Fn. Consider this one as equation 7. Now substitute equation 4 and equation 6 in equation 7. What is equation 4? Equation 4 is F is equal to 0.86 P. And equation 6 is Fn is equal to 120 Newton minus 0.5 P. So by substituting equation 4 and equation 6 in equation 7, we get 0.86 P is equal to 0.3 into 120 Newton minus 0.5 P. In this RHS, 0.3 into 120 Newton is 36 Newton, and 0.3 into 0.5 P is 0.15 P. So the next step will be 0.86 P is equal to 36 Newton minus 0.15 P. Now bring this 0.15 P to the LHS. We get 0.86 P plus 0.15 P is equal to 36 Newton. In this LHS, 0.86 P plus 0.15 P is 1.01 P. So the next step will be 1.01 P is equal to 36 Newton. Now bring this 1.01 to the denominator of RHS. We get P is equal to 36 Newton divided by 1.01. So here 36 Newton divided by 1.01 is 35.64 Newton. So the next step will be P is equal to 35.64 Newton. Consider this one as equation 8. So in equation 8, the magnitude of inclined load P which is required to pull the object towards the right side is 35.64 Newton. Okay, so the answer for this question is 35.64 Newton. So this brings an end to the explanation part of this video. I hope you all would have understood. If any doubts are there, please do comment in comment box. And remember to like, share and comment on our videos. Thank you friends.